All right, lesson 32, trigonometric ratios. So these ratios up here should look very familiar to you guys. You've probably used them a lot. If you've taken physics, you've done them a lot, 10C, math 20-1. So we're going to get more into that, but we're going to relate it now to the unit circle. And we're also going to throw in a few more trigonometric ratios here in a little bit. Similar, they're going to be very similar to these ones, but they should be new for you guys. So let's look at this in the context of the unit circle now. So if we look back to sine theta, right? Sine theta was equal to opposite over hypotenuse, okay? Well, if we relate this to a triangle like shown here on the unit circle, and we assume that the unit circle has a radius or a terminal arm there with a length of 1, right? That r is a length of 1 at that point, right? Then what we can do here, we can rearrange this a little bit. We can say, okay, well, sine theta is equal to opposite over r, which is really just, y is the opposite, right? My value here for y really is the length of the opposite side of that triangle, right? And I have a radius of 1, or my hypotenuse is 1 in this context. Then yeah, so I've got opposite over hypotenuse, y over r, and I know that r is 1. So in the end, I can say, well, that's y over 1, which is really just y. So in the end here, when we're talking about a unit circle, whenever your hypotenuse here is 1, then I can actually say that y is equal to sine theta. They're the same thing as long as my hypotenuse is 1 there, right? And that's going to be handy because we're going to be able to use that in certain scenarios. Okay, now if I look at cos, it's going to be very similar. We're going to have, so now it's x, right? It's adjacent over hypotenuse. So now we're talking about the x value, right? So the x value would be your adjacent right there, right? So that would be my value of x at that point on the unit circle. Okay, so doing the same thing here, we can say, well, okay, x over, and then again 1, right? Our radius or our hypotenuse in that case is 1. So we can say x is really going to be cosine of theta. Okay, that's gonna be very important. We're gonna be doing this a lot, so remember that y is sine, x is cos. Okay, very key that we get that down. Okay, so now referring back to some of the angles that we've been doing, we can actually kind of make sense of why, let's say, typing cosine of 30 gives you root 3 over 2. So let's think about that. So if we had a triangle, right, and let's say we had some point, this is on the unit circle, so this was like a length of 1, and we had some point here of, points x and y, so that would be really the point. So looking at your unit circle there, at 30 degrees, so unit circle, I'll bring that up to remind you here. So at 30 degrees, our x value, right, our x value is root 3 over 2, right? So that's, if this was a triangle, this would be a length of root 3 over 2. And our y value is a half going up and down, right? So if we do that over here, we'll have root 3 over 2 for our x value, and our y value would be a half. Okay, so this, right, this is our x and that's our y. So if we're looking at this, if we're saying, okay, what is cosine of 30 degrees? Okay, well, cosine of theta, we were just saying, is the same thing as opposite, or sorry, is equal to adjacent over hypotenuse. So that'd be the same thing as saying x over r. But since we're on the unit circle, r is 1, right? So I'm just saying the same thing I really said up here, right? Cosine theta is equal to x. Okay, so then if I fill that in, I can say cosine of 30 degrees is equal to, okay, well, what's the x value at 30 degrees? What's the cos value? What's the x value at 30 degrees? It's root 3 over 2. Okay, so if you type in cosine of 30, you would get out, well, this number, you get 0.866, yada, yada, yada. And that's the same thing as root 3 over 2. Now I should preface that with, if you put in cosine 30 into your calculator when you're in radians, you would get this out, right? So just careful on that one. So now, if you look at another example here, let's do the point. Maybe I'll just draw it actually more like a unit circle this time. So if we said the point at 45 degrees, right? So if this is the unit circle, and we're at 45 degrees there, then this point right here, looking at our unit circle there, that you should start to be memorizing, at that point, 45 degrees or pi over 4 in radians, we would get this, right? We get root 2 over 2 and root 2 over 2 for both of them, x and y. Okay, so that would be the point root 2 over 2 and root 2 over 2. Actually, sorry, when I said you had to be in radians for that, I was lying. that would give you this, whether you in degrees or radians. Actually, it should be in degrees because you put it in degrees there. Yeah. Okay. Anyway, so what that means here is that your x would be root 2 over 2 and your y would be root 2 over 2. So then what number should we expect to get out of this? Well, it's looking for sine of 45. Okay, well, what's sine, oh, right down here, sine of 45, or sine theta, I should say, is equal to, well, the sine value there, it's going to be root 2 over 2, right? Root 2 over 2. And that happens at sine 45 degrees, right? So if I type in sine 45 degrees, I get root 2 over 2. I get the y value, right? That's the sine value, the y value. It's going to be really interchangeable here. Whenever I say sine, I mean y. Whenever I say cos, I mean x, right? They're like interchangeable now. Okay, so moving on here. So now tan. I kind of skipped over tan a little bit on the last one there. So let's look closer at what tan is, right? So tan theta is equal to, and from your SOHCAHTOA that we're also used to, is equal to opposite over adjacent. Okay, so in this context, opposite would be your y value, right? If I was like looking at this point right here, right, your y value would be your opposite and your x value would be your adjacent there, right? So that'd be the same thing as saying y over x. Okay, so that's pretty much the gist of it here. So let's say we just try an example. I think that'll help. Let's say tan of 30 degrees, right? So we'll do this point right here. And I know at this point right here is, well, looking at your unit circle again, root 3 over 2, comma, a half. So we'll say root 3 over 2, comma, 1/2. So now when I say tan 30, because it's 30 degrees, and I want to figure out what that is, and that's supposed to be equal to y over x. Okay, well, that's just 1/2, right? 1/2 over root 3 over 2. And then the problem with tan is I got to clean this up a little bit though, right? So we'll write this out again as tan 30 degrees is equal to, dividing by a fraction is the same as multiplying by the reciprocal. So I'll say 1/2 times and then flip that. That's going to be 2 over root 3. Okay, so my 2's cancel. So I get tan 30 degrees is equal to 1 over root 3. But then I don't like it written like that, right? We want to rationalize the denominator. So I'm going to multiply the top and the bottom by root 3. So we get tan of 30 degrees is equal to root 3 over 3. All right, let's do one more there. This will be an easy one. What about tan of 45 degrees or pi over 4? Okay. We'll even do it like pi over 4. We should start getting more used to this too. So let's say tan of pi over 4 is equal to. Okay, so tan of pi over 4 is equal to. So remember, it's opposite over adjacent. So at pi over 4, right, at pi of 45 degrees or pi over 4, remember how this is on the unit circle? This is root 2 over 2, comma, root 2 over 2. Okay, so y over x, or opposite over adjacent, right? That's my y and that's my x value. Then root 2 over 2 over root 2 over 2. Now I can flip all that around and do what I did last time, but really that's something divided by itself. That's just 1, right? So tan of pi over 4 is equal to 1, right? And that makes sense, right? Because remember what tan is. Tan is the ratio of the opposite over the adjacent. I would expect at 45 degrees that this side length, right, the opposite side length, is the exact same length as this side length, right? And that would give me 1, the ratio, right? The opposite over the adjacent. I expected to have 1 for an answer there, right? Okay, so I'm gonna leave it at that. We could have explained a bit more with, like, you know, tangent lines to the circle and everything else, but I think that's sufficient. I think that'll do for now anyway. All right, so reciprocal trig functions. So this is where we're gonna throw in some new things. You guys have probably seen these buttons on your calculator: secant, cosecant, and cotangent. And what they are, they're just the reciprocal of, well, the way it looks down here, right? So cosine theta. So the reciprocal, flipping it around, just means flipping it upside down, right, is equal to secant theta. So just to show you what I mean there, if I would have started out with, let's say, cosine theta, so cosine theta is equal to adjacent over hypotenuse. So that'd be the same thing as like x over r in our example with the unit circle. So then if I'm talking about secant theta, well, that the reciprocal means just flip these around, right? So that's what this is now. It's r over x instead of x over r, okay? And then you got the same thing with sine, so cosecant and sine, and then cotangent and tangent. Now, remembering these, I find cotangent and tangent really easy to remember because they both say tangent, right? These ones you get a little flipped around sometimes because secant goes with cosecant, so it's like the s goes with the c there, right? So it's kind of like opposite of what you might think. So yeah, I kind of remember that they're the opposite of what I might think sometimes, right? So secant goes with cos, and then cosecant goes with sine. Okay, so you'll have to remember that, like, which ones go with which, right? Because that's how you're going to know what to do with it, right? So unless you're using the most recent TI Inspire calculator, you're going to have to convert these these into their primary trig ratios to actually put them in. And really, even if you had this calculator, I think you should anyway, right? I think you should actually just know where it came from. So let's do some examples here. So what do we mean by all this? So this one says determine the value of secant of 200 degrees. Now, this one's just putting in your calculator. We don't have to use the unit circle for that one. So the way we do this, we'd say secant of 200 degrees is equal to, and then it's, well, we have to remember which one it is, right? The secant's the same thing as saying 1 over cos of 200 degrees, right? Those are the same statement. So then you would actually just put this in your calculator just the way you see it there. 1 over cos of 200 degrees. And that's going to give you negative 1.0642. Okay, so 4 decimal places. Now, notice that it had a degrees in there. You need to change your calculator to degrees to get the right answer out of this, right? It's expecting degrees, so we have to put degrees in. Make sure your calculator's in the right mode when you put that in, okay? So now, when we move to this one, this is going to be the same type of question. That's in radians, so your calculator will have to be in radians. Okay, but same thing. So now cotan, and that one's the easier one, right? That's the same thing as tangent. So that'd be the same thing. So I can say cotangent of negative 3 pi over 5 is the same thing. That's equal to 1 over tangent. 1 over tangent of negative 3 pi over 5. Okay, if you put that in, you end up getting 0.3249. All right, now, stuff without the calculators, stuff we shouldn't need a calculator for. So this one says, for what values of theta does tan theta equal negative root 3? All right, so now, these ones are a little trickier with tan. They're not so bad with like, if this would have said this will probably be worth doing. What if the question would have been this? If it would have said, what is sine theta of is equal to root 2 over 2, maybe, or maybe negative root 2 over 2, right? So what I would do at that point, like if this was my question, is you have your unit circle memorized, right? Or you'd pull it out, depending if you were in an exam or not. And you figure, okay, where is sine theta equal to negative root 2 over 2? Okay, well, negative root 2 over 2, that like sine theta, that's my y. It's saying, where is y? Where's my y value equal to negative root 2 over 2? All right, so then I'd be looking at my unit circle. It's there and it's there. So you'd actually have two answers. Your answer would be 7 pi over 4 and 5 pi over 4. They'd both be an answer to that. Or you have 2 for that one. Okay? Now, why I bring that up is because now it's saying tan theta is equal to negative root 3. Okay, that's not, I can't just find that on my unit circle, right? I can't just like say, okay, where is tan equal to negative root 3? Because remember what tan is. Tan is tan is the opposite, right? The y value divided by the x value. So I got to figure out in which of these cases, right? Which one of these would make it turn out so that the y value divided by the x value would end up giving me negative root 3. So we kind of have to do a little bit of trial and error here. We want to just try a few things out to kind of make this work. I think that'll be the easiest way to do this. All right, so I want to come up with negative root 3. Now this will be a little bit of review. Do you guys remember from last year, the cast rule? This might be kind of helpful to get us going on this. This will probably make a bit more sense now too, that you guys have been doing this. We're with cast rule, like why it makes sense. So this is saying that tan is negative. Okay, so according to the cast rule, remember this, I know this is a long time ago, but the way this works is A stands for all, C stands for cos, S stands for sine, and T stands for tan. Well, and that's where they're going to be positive. So tan would be positive here and here, right? In quadrant 1 and in quadrant 3. Okay, so then that would make it so that tan is negative in this quadrant and in this quadrant. So that's really what I'm looking for, right? So it's saying what values of theta is it equal to this? So my answers will look something like this. It's going to be that angle and it's going to be that angle, right? Those are the two angles that I'm looking for because it's saying theta is between 0 and 2 pi, right? Between 0 and 2 pi. 2 pi would be one full circle all the way around, okay? So that's just to get my bearings where I'm after here, right? So now I'm looking for where is this thing equal to root 3, negative root 3. Let's look back at our unit circle here. Now I've got to go opposite over adjacent, or y over x. Now I'm kind of thinking, let's try it out. Like it's probably going to be this one, right? I know I'm over here and I'm down here, or the two places where it's going to be. Okay, and it would probably work out kind of well where maybe we can simplify it down to negative root 3 if I go this one over this one, right? Y over x. So root 3 over 2. So we're going to say tan of, and let's try it out at that point. I'm going to put the point in. This is 2 pi over 3, right? That's this, right? So 2 pi over 3. So I'm saying that tan of 2 pi over 3 would be root 3 over 2 over negative root, or negative a half. Okay, so I'm just typing that in right now. So let's say that is equal to root 3 over 2 over negative 1/2. Okay, so now that's the same thing as multiplying by the reciprocal. So I'll say tan of 2 pi over 3 would be the same thing as root 3 over 2 times 2 over 1. Actually, I'm sorry, that was negative, which is going to work out. 2's cancel. This is the same thing as negative root 3. Perfect. That's what we wanted, right? So 2 pi over 3 is one of our answers. Okay, so theta is equal to 2 pi over 3. But there's probably going to be another one, right? Because we expected that it's also negative down here. So let's do the same thing, but let's find the other one that makes sense, right? It's going to be this one. right? Because those are the same numbers, aren't they? Like we've got root 3 over a half. This one was, you know, positive root 3 over negative a half, and this one's negative root 3 over 2 over positive a half. But either way, that's going to give me the same answer, isn't it? So that's also going to be the case. So that's going to happen at, so just so you can see where I'm looking here, that's going to happen at 5 pi over 3. So 5 pi over 3. So those are my two answers for that one. Okay. Like I said, those ones are a little bit trickier when you got to figure out tan, right? There's a little bit of trial and error, but there's only so many numbers that we're dealing with, so it shouldn't take too long. Okay, next one. For what values of theta does cosecant theta equal root 2? All right, so I'm looking at this being like, how do I interpret cosecant theta as something on my unit circle, right? That's how I was doing the last ones. And in short, you kind of can't, right? That's actually the reason why I'm going to want to change this back to its primary trig ratios. So cosecant theta is equal to 1 over sine theta, right? That's the same thing. Okay, so in that case, then we're going to say 1 over sine theta, right? 1 over sine theta is equal to, well, sine theta is equal to, oh, sorry. So 1 over, yeah, getting ahead of myself here. 1 over sine theta is equal to root 2, right? That's just saying the same thing that we just did there, right? So now if I want to change this to actually sine theta, right? I'd like to say, what is sine theta? Well, this is the reciprocal. This would just be the same thing as 1 over root 2. And now you might still be saying, okay, but that's not on my unit circle either, right? It actually is. It's in a different form. I need to rationalize the denominator here. So I can say root 2 over 2 for the top and bottom. So that's the same thing as root 2 over, and then root 2 times root 2 is just 2. That one is on my formula sheet, or my unit circle, I should say. So it's really saying, where is sine theta equal to root 2 over 2? Or where is y equal to root 2 over 2? So let's look, and it's positive, right? So that's the other part of this. So where is it positive? Now, won't it make sense that everything I'm looking for here should be above the x-axis? Because I'm looking for positive root 2 over 2, like a y value of root 2 over 2, and a y value of root 2 over 2, right? So that's where it's going to happen. It's going to happen at pi over 4 and 3 pi over 4. Okay, so you'd say theta is going to be at pi over 4 and 3 pi over 4. Oh, and I did that in radians, but it actually gave us the restrictions here. So it's between 0 and 360. It gave it to us in degrees. So we probably should have our answers in degrees too, just kind of based on what they give you in the question. So pi over 4, that's the same thing as 45 degrees. And then 3 pi over 4 is the same thing as 135 degrees, right? And that's written on here too, right? But like I said, you should start memorizing these. So yeah, 135 would be right there, okay? All right. Determine the value of the other 5 trig ratios if secant theta is equal to -5 over 3. And this is important because they threw this in here, right? Theta is greater than 0, but it's less than pi. Now, remember what that means. This is my unit circle. That's saying, so remember pi is over here. That's saying that I'm only talking in this range, right? I don't have to worry about down here. So that's what we're restricted to in this case. So now, let's get our bearings here. This is saying, so secant theta is equal to this. So secant theta, though, is the same thing as saying 1 over cos theta. Okay? So 1 over cos theta is equal to, well, and I'll do this right now. Cos theta, remember, would end up being your adjacent over your hypotenuse, right? So in this case, this is going to be your hypotenuse over your adjacent. Okay, just flipping them around, right? Because it's just backwards there. Okay, so that'd be the same thing as just saying r over x. And you know what I think will help here too? Let's sketch this thing out. So again, let's get our bearings, make sure we're doing this right. Say cast. So I can say, okay, where is cosine? Because really, if secant is negative, then cos would be negative as well. So where is cos negative? So cos is negative here and here, which makes sense. That's where x is negative, right? That's where the x values are negative, or on the left side of the y-axis there. Okay, so if I sketch this out, I think it'll make a bit more sense. So that's my Cartesian plane there. And we're over on this side here. And looking at this ratio, right? Well, here, let's put the numbers in for the last one there. So 1 over cos theta is equal to, so r over x. Oh, sorry, let's figure out what cos is. I think that'll make more sense. So let's say cosine theta is equal to adjacent over hypotenuse, which is like x over r. Then the adjacent in this case, so let's say -3 over 5, right? Just flipping these two guys around for our cos. So in that case, so cos is going to be -3 over a hypotenuse of 5, right? So those are the two things that we know from our triangle so far, -3 and 5. Now we don't know the backside yet, right? And this also makes sense with secant, right? Secant was equal to the hypotenuse over the adjacent, so the hypotenuse over the adjacent, right? So it'd be the same thing, right? But anyway, yeah, we don't know the backside yet. So this is just Pythagorean theorem, though. I can say y squared is going to be equal to 5 squared minus, you can do -3 squared if you like, but either way, that's going to come out positive. So it's really just 3 squared. So doing all that, you would end up with 4. Unless you guys solve Pythagorean theorem yourself, but this would be 4, which makes sense. This is a 3, 4, 5 triangle. Okay, now that we have all those written down, now the next part's easy, right? Now, once we have our triangle figured out, then we're just kind of throwing them into where they belong. So it says the other 5 trig ratios. So I already figured out cos theta. So here, let's write all 6 of them down. So we'll say secant theta was what they just gave us. That was -5 over 3, which was hypotenuse over adjacent. Now cos theta is equal to -3 over 5. That makes sense. Those are inverse of each other, right? Now let's do the next ones. So let's do cosecant and secant. Here, it'll probably be easier to do sine first and then flip it. So sine theta is equal to, so remember sine is opposite over hypotenuse. Opposite over hypotenuse is 4 over 5. And positive, right? 4 over 5. So that would make cosecant equal to 5 over 4. We just flipped around, right? Okay, now tan. So we'll do tan theta. So tan is equal to opposite over adjacent. So that's 4 over -3, or -4 over 3. So then that would make cotangent theta equal to -3 over 4. And there you go. There's all of our trig functions. There's all 6 of them, right? Hopefully that made sense. We did do some of that stuff in 20-1 as well, right? Now, you guys may or may not have this question on here too, but this is actually an old diploma question. I thought it'd be worth doing because it's the type of question that you would get, right? So this one says, is secant theta is equal to 13 over 12. And then it says where theta is greater than 3 pi over 2 and less than 2 pi, then the value of cosecant theta is. Let's get our bearings where that even is, right? Which quadrant they're talking about. So remember, 3 pi over 2 is straight down. That's this way. And then 2 pi is right there. So we're in this quadrant is what they're saying. We're in quadrant 4. Okay. So now let's figure out what we're even looking at here. So secant theta, right? So secant theta, that's the same thing as, or it's the inverse of cos. So let's just do this. We'll say, well, cos theta then must be 12 over 13. Okay, I find that a little bit more useful, right? Now let's draw that triangle of what we're looking at here. So if we were drawing our Cartesian plane again, and we know we're down here somewhere, right? And we drew a triangle up to that point, then what do we have when we're looking at cos here? Well, this is so cos is adjacent over hypotenuse. So that means this is 12, and that means this is 13, right? The hypotenuse, right? Adjacent over hypotenuse. Adjacent over hypotenuse. Now, what are they looking for? Well, they're asking me, what is cosecant theta? So cosecant, what might be easier because we're more used to this? Let's figure out what sine theta is and then flip it upside down. So sine theta is equal to opposite over hypotenuse, right? Or y over r, either one, right? Okay, so this requires, though, that we're going to need to know what the opposite is. Okay, well, we've done this before. Pythagorean theorem, right? So we'll say y squared is equal to 13 squared minus 12 squared. So y is equal to, sorry, one sec. 13 squared minus 12 squared. Oh yeah, of course. So that's 25. So then y would be equal to 5, right? Taking the square root of both. So now that I have that, I'm pretty good to go because that's 5. But they're kind of tricking us here. They're testing us. It's going down. This is really -5, right? That's going to matter, right? That's going to matter what they get for an answer to this. So that's -5 going down. Okay, so now I have everything I need. So let's say, okay, what is sine theta? So sine theta is equal to, my opposite is -5 over 13, right? It's opposite over hypotenuse there. And then just let's flip this around though, because cosecant is the inverse. So cosecant theta is equal to -13 over 5. So -13 over 5. And you can see where the distractors could have thrown us off there, right? 13 over 5, you might, if you forgot the negative right here, you might have went perfect, 13 over 5, and you would have circled the wrong answer, right? Careful on these ones. It's really easy to make a mistake on those. And then if you would have got it mixed up with sine, I guess, you would have had 5 over 13. If we would have got carried away and forgot to actually flip it at the end there, right? So, okay. So hopefully that made sense. Yeah, I'll see you guys in class.